Okay, recall a perpendicular bisector. Perpendicular bisector divides something in half. So we've got two equal pieces, and it makes a right angle. So this says it's a line or line segment that is perpendicular to a segment at its midpoint. In the figure to the right, blank is the perpendicular bisector of blank. So let's fill that blank in. Yeah. What is the perpendicular bisector in this picture? Lynn? Line, CP? Because it could be Ray if this side didn't have the thing on it, but yeah. So line CP, not a lot of space in there. And that is bisecting what? Avni. Segment AB. So remember, if we are talking about a line, I'm going to write this bigger. If we're talking about a line, we put the little arrow above it. If we're talking about a segment, it's just the line without the arrows. If we're talking about measurement, we don't put a line at all. New vocab, perpendicular bisector theorem. In a plane, if a point lies on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment. Okay, C is on the perpendicular bisector, so C so what it's saying is any point on this perpendicular bisector, any point is going to be the same distance to A and to B on this perpendicular bisector. Okay? So if C is on the perpendicular bisector, it's going to be equidistant to these endpoints. So what that's saying is CA is congruent to CB. And we'll mark that in the picture. P is on the perpendicular bisector, so what could we say? AP is congruent to BP. And that's already marked for you. And the perpendicular bisector converse is this one just backwards. In a plane, if a point is equidistant from the endpoints of a segment, then it lies on the perpendicular bisector of the segment. So here we've got a perpendicular bisector, and I know that because it's perpendicular and I see the two sides are congruent. Down here I've got point D, and these two sides are congruent. So this is telling me that this will eventually pass through point D. So D is on this perpendicular bisector. If P is the same distance from A and B, what does that tell us? P is the midpoint. Oops. P is the midpoint of AB. What other point is the same distance from point A and B? Point D. Point D is on the perpendicular bisector. And since you guys are using Cami, you could like change color and color code stuff really easily, right? Right, Stephen? All right, find the indicated measure. Again, if there's no line above it, we're talking about measurement. RS. What's the measurement of RS? Alex, what's the measurement of RS? 6.8. Excellent job. We know that because Q is the midpoint of RP, and it's perpendicular, so this is a perpendicular bisector, so these have to be the same. That's the perpendicular bisector theorem. Perpendicular bisector theorem. Can somebody help? They fix it? Okay, good. So you need to still get that downloaded? Okay. All right, right here, the segment EG. EG is how long, Denise? I couldn't hear you, huh? Well, you'd agree that this is 9.5. Okay, so 9.5, we're going to add that together. 9 and 9 is 18. So what's 0.5 and 0.5 give us? Yeah. Good. All right, and then the third one, AD. We need to find AD. So what do we know is true in this picture? John, what do we know is true in this picture? Okay, well, what do I know about their lengths? Their measurements. This is true. Those are I couldn't hear you. Well, that's just the figures themselves, but when I talk about measurements, I'm talking about just AD and CD, but we're not talking about congruence anymore. When I talk about measurements, what am I talking about? Can anybody help him out? When I talk about congruence, we're talking about the figures, but when I talk about measurements, I'm not talking about congruence. What goes in here instead? This is review from last semester. Yeah, equals. So you're going to say they're equal to each other. So now what is AD? 5x. And what is CD? 3x plus 14. So that's your substitution. We're going to solve that equation in 7. Is that my answer? No. Rakaya, why not? Right. We want to know AD, so we have to plug in for x. We need to know 5 times 7, which is 35. There we go. Excellent. We can handle this. Did you catch up? Okay. I can give you this when we're done for you to fill in what you missed. Okay. You try. Try them. Quick. Go. Now, as you guys are working on Candy, does it just automatically save? Okay, that's good. That's good. Well, there's also a save button. Just in case you're like worried. All right. Ryan, did you get A? What'd you get? Excellent. Raylan, did you get B? Very good. 10. And then I'll work out C. You should have done 3x minus 8 equals 2x. X minus 8 is 0, so x equals 8. We're finding GH, so we got to plug that in. Times 8 minus 8. Did I make a mistake yet? Am I doing okay? That's what you did. 16. Okay. All right, the other part of today is angle bisector. Excuse me. A ray that divides an angle into two congruent adjacent angles. In the figure to the right, blank is the angle bisector of blank. So in this picture, what is bisecting the angle? Cameron, in this picture, what is cutting the angle in half? A little bit louder, hon. Line DA. Okay, I'm going to go the other way. I'm going to say AD, and I'm going to call it a ray. Okay, but totally right. I'm going to say AD, and I'm going to call it a ray because it's starting at A and going. And it's bisecting which angle? Jesse. Okay, hold on. I'm going to draw something. So this is cutting what angle in half? So it's going to be one angle. So when you say angle B could be this, it could be this one, it could be this one. That's not what you mean, is it?
No, I just don't really know how to say it.
You've forgotten.
Yeah, I
Have a break. I'm so sorry, guys. AD is touching one of the angles.
Yeah.
Which angle is it? What letter is it touching?
C.
This yellow part is not touching C.
A.
It is touching A.
Okay.
And then down here it has these two markings, which I'm making even bigger, showing that these are congruent. Now, because there are actually three angles right now that you see by angle A, we're going to name it with three letters so we know which one we're talking about. A has to be the middle letter. So you're going to say BAC. So if I'm going to draw that angle, BAC. Or you could write CAB. You could go the other direction. CAB. How is an angle bisector different from a segment bisector? Stephen, can you answer my question? How is an angle bisector different from a segment bisector? There's a segment bisector. There's an angle bisector. How are they different? One's a line and one's what? In this case, yes. I think this one could be a ray. So I would say there's something more. Matthew, can you add on something to that?
Instead of it bisecting it and having two congruent segments, it has two congruent angles.
Sure. This one makes two congruent segments. This one makes two congruent angles. You got to use the words angle bisector or segment bisector. Okay? Another thing that you could say is that the segment bisector, what does it pass through? The what of the segment? It passes through the midpoint. This one over here does not have a midpoint. It's like the vertex of the angle. There's another way that they could be different, what they pass through. Distance from point to a line, this is something we covered last semester. The length of the perpendicular segment from the point to the line, sorry, distance from a point to a line is the length of the perpendicular segment from the point to a line. In the figure to the right, the distance from point D to ray AB, from point D to ray AB, I don't think this is making sense to me. Oh, maybe it is. That doesn't make sense to me. Ignore this. I have to go back later and figure out what it's supposed to say. Oh, wait, maybe it's talking about this one. That's probably why it doesn't make sense. Never mind. But in this one here, the distance from point D, this point D, to ray AB, from point D to ray AB, has to make 90 degrees. So from point D to this ray AB, dB is the distance. So when we have distance, it has to be perpendicular. So in this figure right here, the distance from point A to line L, out of all of these lengths right here, which one of them is the distance from point A to line L? Here's point A, here's line L. Out of all of these lengths, which one has to be the distance? Aaron, do you know? Have I called any of you yet? Aaron, it has to be perpendicular. I need a segment. From A to D would be the distance, because that's the one that's perpendicular. That's how we know. That would be the distance. So I'm going to write AD, and I wrote it without a line above it because it's the distance. So distance has to be perpendicular. Here's new vocab, angle bisector theorem. If a point lies on the bisector of an angle, it's equidistant from the two sides of the angle. D is on the angle bisector, so so what is congruent to what? DB is congruent to DC. Got that? Because I got to go to my next page. You got it? And then the converse, the angle bisector converse says if we know that these two segments are congruent, the distance between them is the exact same. If a point is on the interior of the angle and is equidistant from the two sides of the angle, then it lies on the angle bisector of the angle. So if I know that DB and DC are congruent, I can say that AD is the angle bisector. So I'm going to say AD is the angle bisector. This is actually probably not what's supposed to be in this blank. Angle bisector of angle BAC. I think what's supposed to be there is that angle BAD, bless you, is congruent to angle CAD. I think that's what's supposed to be there. If these two are congruent, then these two angles are going to be congruent. Almost finished for today. We're doing okay? All right, so in this picture, we've got measure of angle GFJ. GFJ, I need to find this one right here. What do we know? Well, we know that these two sides are congruent and they're perpendicular, which tells me FJ has to be the angle bisector. So what is this angle in here? Jay? Have I called on you yet? Jay. Yeah, what's GFJ? So we're talking about angle bisectors. This one's 42. What do you think this one is? Yes, 42 degrees. Make sure you guys put a degree symbol. In this picture, I know that these angles are congruent because I know that these angles are congruent, and I look out here, these are perpendicular to each side of the angle, which means these two have to be congruent. That's using the angle bisector theorem. So that's telling me that 5x equals 6x minus 5. And when I solve that equation, I get x equals 5. Is that what it's asking me to find? No. It's asking for RS. Do I have to plug it in 6x minus 5? Could I plug it in 5x? Why? It should be the same answer, right? I'll just do both of them just in case. Yeah. So RS is 25. That's one way to just check your answer and make sure that you're doing it correctly. If you're unsure of yourself, they should be the same answer. All right, you try. Measure of angle ABC. ABC. Find the measure of angle ABC. Who have I not called on? I know I haven't called on Emily. Who else haven't I called on? David, did I call on you yet? Did I call on you yet? Okay, there's two of you. Emily, what do you know about this angle right here? It's what? This one right here. It's 56 degrees. So I'm asking to find ABC. Could you tell me it? Mm-hmm. What are you adding? Plus what? Okay. 6 and 6 is 12. Yes, 112. There you go. Good. All right, and then JM. David, how am I going to set up this one? Tell me what to write down.
4x equals 2x plus 12.
Okay. Subtract 2x from both sides. Divide by 2. Then plug back in. What'd you get, David? Good. All right, very last section goes with graphing. What do we remember about parallel lines? What kind of slope do parallel lines have? Lynn? Same slope. How about perpendicular lines? There's two words. Perpendicular lines have what kind of slopes? Avneet? Opposite reciprocal. What is one exception to this rule? I would say if what is it called? There isn't an exception to this rule, but if one was perpendicular and one was horizontal, but I don't really think there's an exception to this rule. Write an equation of the perpendicular bisector of the segment with endpoints at -2, 3, and 4, 1. So we need a perpendicular bisector to this segment with endpoints at -2, 3, and 4, 1. So here's P and Q, those are the ends. The perpendicular bisector has to go through the midpoint of these. And it has to be perpendicular to this segment. So the answer is there, but I'm going to show you how we would get there. All right? So we need to find the slope of PQ. We're going to find the slope of PQ. You could, if it's graphed, you could count it on the graph, or we could use the slope formula, which is y2 minus y1 over x2 minus x1. So 1 minus 3 over 4 minus -2. -2 over 6, just -1/3. So that's the first thing I'm going to do is I'm going to find the slope of the segment with the endpoints PQ. My second thing that I'm going to do is I'm going to do opposite reciprocal slope. So opposite reciprocal of -1/3, Alex. +3 or 3 over 1. And then the next thing we're going to do is we're going to find the midpoint of PQ. We have the slope, now we need a point. So we're going to find the midpoint. Remember, the midpoint formula is to average together the x's and average together the y's. The actual formula looks like x1 plus x2 over 2 and y1 plus y2 over 2. That's the formula, but I just think about averaging the x's and averaging the y's. So my x's are -2 plus 4. My y's are 3 plus 1. And I get my 1, 2. Okay, so now we're going to find the equation. So we're going to plug all this information into y equals mx plus b. We just need a point and the slope, which we have right here, point and slope. And then we have to find b. So my y value is 2, my m is 3, and my x value is 1 plus b, which we don't know yet. So I'm going to subtract 3, and I'm going to get b equals -1. And then my last step would be to write the equation, which is y equals mx plus b, which is y equals our m is 3, x minus 1, which was our b. And you can see that's the answer that they have over there. Now I realize there's probably not a ton of space in that little area that you have. So I'm just going to do this one more time for you to see it again. Okay? Now when you guys are scrolling on your Cami, are you able to like see the two at the same time? Is there enough? I mean, if you're zoomed out enough, can you see both of them at the same time on Cami? Or does it put like a huge page separation in there? No? That's good. This one probably doesn't have a ton of space either. All right, so write the equation. So this one is not graphed for us. So we can graph it if we choose that we want to look at a graph to find our slope or the midpoint or anything like that. You could totally do it using the graph. I did it all algebraically here, but we can do it using the graph as well. So let's graph -1, -5, and 3, -1. -1, -5, and 3, -1. We're going to find the perpendicular bisector of that. So step 1, what should I do? This doesn't have any letters. Let's call it XY, okay? Because that way we know what we're talking about. Step 1, what's MPQ mean? Does anybody remember lowercase MPQ? What did I write there? Maggie, you remember what this stands for? Right, so if you forget, like if you're looking back right now and you're like, I have no idea what M is, then you need to make yourself a note. This is slope. Like lowercase m is an abbreviation that stands for slope, but if you forget already, you know you're going to forget later. So write that in as slope. So we need to find the slope of our segment. So you can count rise over run if you'd like. 1, 2, 3, 4, 1, 2, 3, 4. So up 4 over 4, which is 1. Or you can use the formula which I gave you in the previous example. Step 2, we need the opposite reciprocal slope, which is the perpendicular slope. So what is opposite reciprocal of 1? -1. So that's our slope we're going to use. Step 3, we need the midpoint. If you're doing this on the graph, you might be able to figure out the midpoint really easily. Can anybody see it on the graph? Sorry. Can you guys see it on the graph? If not, then do it algebraically. I know what it is because I can see it, but not everybody has my keen sense of eyesight. I don't know what I'm talking about. So if I average my x's and I average my y's, I can get the midpoint that way as well. So add together -1 plus 3, which is 2 over 2, 1. And that's -3 over 2, no, -6 over 2 is -3. So 1, -3 should be the midpoint. I go over here, 1, -3, that's where I thought it would be. 1, -3. So there's my point. I need slope, and I need point, and now I'm going to do y equals mx plus b. Oops. So my y is -3. My m is -1, and my x is 1. Add 1. B equals -2. So my answer should be y equals -1x minus 2. Do I have to put the 1 here? Can I just put -x? Okay. So that's it for today. We have a worksheet. All these exact same kind of questions on the worksheet. And you guys have 6-7 minutes to start now. If you felt like this is where you're going to need the most help, maybe start at the last couple questions first. Okay?